So in this video, I am going to read your answers and anonymously, I will tell you what your friends, what your classmates wrote and why they are wrong. Okay, so it's question one from the final exam. Let's see. It's identification, basic identification problem. And the first question is state the exogeneity condition. I thought it's really a free question. The correct answer is you have exogenous variable in x1 and you have exogenous variable in z2. So the correct answer is x1 epsilon I cross product expectation is 0 and z2 epsilon cross product is 0. So you have to write both of them. They are together exogeneity condition. Or equivalently, you may write zi epsilon I equals to 0. So because it combines both. So that is what you should have written. So for example, there I'm looking at your answers. If you write only this part, that is wrong. And of course, x2I epsilon I is wrong. I wrote may not be 0. It is not 0. So this is obviously wrong. What else? And we do not need this assumption. It is unnecessary. It is unnecessary, so that is wrong. Okay, that was from question part A. Part B, what is the order condition? Let's go B and C together. They are correlated. So B is just order condition. That means number of instruments must be at least equal to the number of endogenous variables, right? So simple, that's simple. But some of you wrote homoscedasticity and no autocorrelation. I cannot explain why that is wrong. It is just has nothing to do with the intended order condition at all. Homoscedasticity doesn't mean anything here. Right, and yeah, all of you have done well, and so and then the difference between the order condition and rank condition is even if order condition is true, then still it does not guarantee identification. It is not a necessary condition, but sufficient. I mean, it's not sufficient. It is necessary condition. But even if order condition is wrong, then automatically identification is impossible, right? So we go to rank condition. The correct rank condition is this rank condition equals dimension of beta. Okay, let's count the dimension. So z is m by 1 and x is 1 by k and beta is k by 1. So the expectation is m by k matrix. So for the rank to be k, this is of course k, which is number of unknowns. Okay, so this is what we have. Let's see what you wrote. Some of you wrote rank. So notation error. Rank of xi zi xi transpose. This is still random. The expectation is not taken, so it is random. And some of you said expectation of zi xi transpose is k. It is matrix and it is a number, so it does not make sense. And some of you wrote rank of expectation of z2i x2i transpose is k2. Okay, I understand what it means, right? So you are only looking at the relationship between the instrument and the endogenous variable, Okay, like ignoring x1, because x1 is exogenous and does not have any problem. But this problem does not rule out. Problem with this answer is potential multicollinearity between x1 and z2, right? So it's not ruling out a multicollinearity problem like involving x1. So in that sense, this answer is not correct. Okay, let's see what kind of answers. I am looking at an answer that another guy wrote. Anonymous answer was something like this. Is full rank. Here, frankly, I cannot understand. Maybe so. It is coming from the assumption that epsilon has mean 0. Then I understand what this guy wanted to say, but it is not right because we did not make this assumption at all. That is the problem. But if we had this assumption, that is right. And the same problem, it does not rule out the multicollinearity between x1 and z2. X1 and z2 and x1 and, let me see if that's right. Yes, right. So that is not good. And also the dimension does not match. Here, you think about it, it is k1 by 1, it is k2 by 1. And I think this guy meant, say, just k1 by m2, k2 by m2, right? So, in the end, it becomes the dimension does not match because it has k1 rows and it has k2 rows. If they are different, the matrix cannot work. So to be more correct, you have to put transpose here. And then if you correctly transpose those vectors, you had to have 1 plus m2 by k1 plus k2 dimension, right? This is k, but this doesn't mean anything, right? We may not have, even if m2 is greater than k2, still we cannot be sure that 1 plus m2 is greater than k1 plus k2 if k2 is larger than a certain number, right? So it may be wrong, then no identification. So that's why this answer is wrong. So this answer cannot identify the parameter, so it is wrong. Let's see what other answers are. Similar, like pretty much similar answers like about rank of part of the regressors, something like this, rank of expectation z2 x2 does not cannot be considered like as a sufficient condition for the identification, right? Let's see. And I was surprised that none of you used the simplification assumption. I think none of you stated you are assuming that, like, say, k1 is 0 or m is 1, k2 is 1. Those simplification assumption was not used. And then let's go to the final question here. Prove that it's identified under those conditions. So this part was not as bad, but let's see where the problem was coming. I'm reading your answers now. Many of you have done pretty well. One of you tried to do the fitted value approach. So as I will explain in question 2. Fitted value approach is okay, but in many aspects, theoretically that is not simple. So should be much more careful, and especially what I wanted to say here is x2i is z2i prime gamma plus u. This is wrong because the dimension does not match. It is k2 by 1 and z2 is m2 by 1. Then how can you make it k2 by 1? So it should be k2 by 1. So does not match. So that's why I made a mistake. And second mistake is you have to include x1 here. The correct notation should be x2i equals gamma 1 0 times x1i plus gamma 2 0 times z2i plus ui. Then the dimension is k2 by 1, k2 by k1, k1 by 1, k2 by m2, m2 by 1, k2 by 1. So in class, I explained that it is so much demanding, like very, very annoying algebraically. So I'm not considering this in this case. It is possible, definitely possible, but I won't do it because there is a better way. GMM or the moment condition approach is much easier way. And I'm reading another answer. What is it? I think it is an algebra mistake, but the answer goes like let me just copy the answer. Expectation of z x1i transpose beta 1 0 plus epsilon I minus x2i beta. I don't know what it means. So already it gets wrong, and this guy wrote it as z2i x1 xi transpose beta 0 minus beta. Hard to understand what's going on. And in the end, wrote beta equals z2i x1i transpose. I don't know where it came from. And then suddenly it equals z2i. I don't know. Hard to read. Something like this. Hard to comment what is wrong, where is wrong. I believe it is an algebra mistake. And let's see. That's that. And another guy just did not show the identification. And another problem is that so this guy set up a linear system of equations, excuse me, starting from expectation x1i yi, expectation x2i yi equals expectation x1i squared, expectation x1i x2i, expectation x1i x2i, expectation x2i squared times beta 10, beta 20. This is great. But this guy did not say so, but had to need assumption that dimension of x1 is 1 and dimension of x2 is 1 to write as a square. This is true. And then this guy wrote beta 10, beta 20 equals expectation x1i yi, expectation x2i yi times this matrix, 2 by 2 matrix, those 2 by 2 matrix inverse. It is wrong because you have to multiply, say, put it this way, a times x equals b. You are multiplying a inverse in front, a inverse times ax equals a inverse b. So x equals a inverse b. This is true. But what is wrong is if you multiply a after post multiply a inverse, then it does not imply x equals ba inverse, right? So this a and a inverse do not cancel out. So it is wrong. And from here, still, surprisingly, in the next line, it became correct. Another minor mistake is the inverse of a matrix. So if you think about 2 by 2 matrix ABCD inverse, you know it is AD minus BC and change position and minus B minus C. So this guy forgot minus signs here, and then tried to calculate beta 1 as a complicated equation, like by inverting the matrix. But somehow, in the end, it is, this student said this, like, so equation goes like this, x1, x2i squared, x1i yi plus expectation x1i x2i, expectation x1i yi, and divided by expectation x1i squared, x2i squared minus x1i x2i total squared. So my first comment is maybe I think minus sign is missing here. It should be minus. And also, this equality is obviously wrong. I told you many times about this. This, I don't know why you are sticking to this formula. This is true only when y is alpha 0 plus beta 0 xi plus epsilon with scalar x. Xi must be real number and there must be intercept, right? In our case, we have, for example, the formula fails if you have alpha 0 plus beta 1 x1 plus beta 2 x2. Then the formula does not work. So you have to be careful. The formula is not omnipotent. It's not right. Okay, and other questions. Okay, overall, the identification part is pretty straightforward, so did well. In the next video, I will talk about your estimation answers.